Welcome everybody to day 2 of the World Fair. Our talk today is tips and tricks from the International Exhibition of FME. Those were the scenarios that we walked into yesterday with our fabulous guest speakers. Today we're going to be getting into the nuts and bolts of how some of these scenarios work and walking through at a more technical level how you can implement these things yourself. Quick bit of housekeeping. We'd love to hear your questions. Please ask them in the question panel, and our team today is going to be happily answering them as we go. But first, let's do a round of introductions. My name is Brian Pont. I'm the Director of Customer Success here at Safe Software. And yesterday I shared kind of my favorite memory of a fair that I've been to in my life. Today I want to talk about the rides because we all like, I won't say love, but we all like to go on rides at fairs. And I think my favorite one that I've ever been on is the various different bumper cars or bumper boats, if you've ever been on those. As Jen likes to call them, they're Dodgem cars. And I definitely love any chance that I get to get on one of those and smash around. Chris, do you have a favorite memory, favorite ride?
Yeah, so I'm Chris Berger, an FME technology expert here at SAFE. And I'm honestly not a big fan of roller coasters, but you can often find me at the skill testing games or having some mini donuts. How about you, Mark?
Hi, I'm Mark. I'm an FME server expert. And my favorite ride is probably the, sorry, I need to redo that. Hi, I'm Mark. I'm an FME server expert. And my favorite ride is probably the pirate ship swing. How about you, Jen?
Yeah, so I'm Jen. I'm an FME cloud expert at SAFE. And I would say my favorite ride, it probably depends. If we're talking about a small fair that would like come to town, probably the waltzes, which is kind of like an intense version of the teacups. And a roller coaster, there's one in the UK which like brings you up really high and then like holds you over the edge looking down for like 3 seconds and then just plummets you down. So I would say those two.
Yesterday, we grabbed some cotton candy and popcorn. We explored the fairgrounds, and we were inspired by 6 of the most common scenarios that our FME experts see every day. Today, we're going to take a backstage tour of how all these different rides work. For each scenario, you're going to hear the top tips and tricks to help you recreate that magic at your own organizations. So grab your tool belts. Let's get started. Now, the first category that we want to focus on is streamlining operations. And as a bit of a thought exercise, I want you to imagine yourself at your desk working on a task that you feel is just a bit repetitive. Wouldn't it be fantastic to be able to automate that task, saving time for other aspects of your role, perhaps setting it up so that it can run overnight when you actually are sleeping when it happens? Let's chat with Chris, who will talk us through some of the tips and tricks he's learned to help create automatic processes.
Let's take a closer look at digital plan submission. Digital plan submission is all about receiving and validating to ensure only high quality data enters your system, while at the same time improving operational efficiency by automating the validation process. This can be done in a number of ways, but I'm going to walk you through an example of how to accomplish this using FME Server Workspace and Gallery apps. As you'll see in the demo, both Workspace and Gallery apps are easy to build, maintain, and using them is as simple as filling out a web form. Although Workspace apps will appear simple to end users, you can have a sophisticated workspace performing a thorough validation behind the scenes to ensure only submitted data meets your organization standards. Validation can be performed on the entire dataset, including things like the file name and the metadata to keep it basic, or you can go down to the schema validation to ensure layer names, for example, of the submitted file meet your organization's specifications, and even down to the geometry and attribute level to ensure all features are correct and no geometry issues exist, like undershoots or self-intersects. One of the main benefits of digital file submission is that it enables users to easily upload their files in addition to receiving instant feedback regarding their submission status. Since an FME workspace is driving the validation, you have the ability to create flexible and informative validation reports by providing end users with details about why the submission failed, from a general summary down to which individual features failed and why. From the GIS professional's perspective, this is a huge time saver because invalid submissions and data sets that don't meet the specified requirements are never going to reach your desk. This means you won't be buried in invalid or incomplete submissions, so you'll be able to focus on that other project you have on the go. Let's consider the local government example. Development projects often require multiple permits from various departments, and one great way to organize this is using FME Server Gallery apps, as it acts as a centralized submission portal for all things development related. This can be used to inform the end user about everything they need to request and submit for approval, in addition where they can find additional forms and guides, if needed. This is possible because gallery apps can link to either existing workspace apps, which we'll see in the demo, or to an external URL. Submitting a development permit shouldn't really be a daunting task. Using workspace apps is a great way to simplify the process because you can utilize things like published parameters to ensure end users provide all the required information along with the file that they're submitting for validation. Since published parameters can be optional or required, this is a foolproof way to ensure required inputs such as things like application type, project address, or other key information is provided along with the project data. Behind the scenes, the validation is being performed on the files is really just a workspace you built in FME Workbench. And this is going to be all the business logic that you set out to meet your organization's requirements. If your organization's standards include certain layer names to be provided, it's also easy to perform validation on a per layer or a per geometry, or even at a per attribute basis. All of this can be achieved by taking advantage of things like the filter type transformers, such as the test filter, the attribute filter, and even the feature type filter, as they enable you to determine which features are sent to each direction in the validation process. So what happens if a submission fails? Well, there's no smoke and mirrors here. Since you're validating the submission with FME, you're able to provide the end user with detailed information about why it was unsuccessful and why the submission failed. Since all of the attributes and geometry data are available to you in the workspace, it can also be provided in a validation report that's returned to the end user in the form of tables, lists, and maps to ensure they know why it failed to submit and give them an indication of why or what they need to do to repair their data set in order for resubmission. How about a successful submission? At this point, the data can be either fully integrated into your system or into a Delta table if you require human intervention to reconcile and post the changes. Regardless, this is a huge time saver, as the entire checklist of validating the geometry, schema, and the attribute data has been taken care of by the validation being performed by the Workspace app. If your submission also requires follow-up actions from the end users, you can provide this information in the successful submission report. For example, what's next in the permit, when's their payment due, or when can they expect to hear back about the approval? All of this information can be provided in the submission report, so the end user is kept up to date. All right, let's take a look at how we can put a digital plan submission app together like this. Here we are in FME Workbench, looking at the CAD to GIS validation workspace. We're going to be reading in the user submitted CAD file, validating the schema, validating some attributes, and writing it out to our geodatabase. We'll also be providing an HTML report back to the user to indicate whether the submission was successful or they need to revise the CAD file and resubmit. We'll use the Published FME Server button at the top here, and we'll walk through the publishing dialog. We're good with the file name on record, so we'll look at the registered services now. Since I'm writing to two systems, we're going to be writing to our geodatabase and creating an HTML report. I'm going to want to make sure that our HTML writer is included in this service. Looks all good, so we'll publish it to FME Server. Now in the FME Server web interface, we can go into the Server Apps option on the left and build our first Workspace app. Here I have some basic information already filled out, but it's just as simple to fill out the name of the app, give it a title, point it to the repository where you uploaded the workspace, and point it to the workspace itself. We already have the data streaming service selected, and that's the correct one in this case. So we'll scroll down, and we can take a look at the parameters from that workspace. In this case, all the parameters that we included want to be visible in this app, so we'll go ahead and leave all those selected by default. We also have the option to customize, so if we wanted to give it more of a branded look, we can do that. So I'll go ahead and drag in an image here for the heading logo, and you do the same for the icon, the banner, and the footer logo as well. You also have the option to add some footer text if you desire. So we'll click OK, and that will create our Workspace app. It's given us the link to the Workspace app, and we can open this, or we can add this to a gallery app. On the Build Gallery App page, we have the same options to specify a name and a title for the gallery app. What's a little bit different than the Workspace apps is you have the option to add links. Now, links can be pointed towards Workspace apps or any URL on the web. In this case, I'm going to point it to the gallery or the workspace app that we've just created. I will upload an image for it and call it development permits. And I'll add the link. I can also position it to the correct spot in the gallery that I'd like it to be. If I scroll down to the bottom, I also have options to customize just like I did on the workspace app. So I'll go ahead and add an icon. Looks good. And we'll add a logo as well. Then I can go ahead and click OK, and it will create the gallery app and provide me with the link to the gallery app. So let's hop into the gallery. Now you can see in the gallery, this is a very clean, centralized location for all things permitting. We can get our development permit, we can submit our development permit, we can submit our electrical and our plumbing permits all in one space. Let's take a look at the development permit. We can go ahead and fill in the published parameters as the FME lizard, and we can drag in our file to run the workspace validation. Click OK to run the validation workspace. Here are the layers that I've submitted, and here are the layers that are expected as mentioned in the CAD standards. And if I scroll down to the bottom, I've also included more detailed information about the individual features as well. So all of this information, like the entity handle that is going to need repair, is all available in the workspace and can be displayed back to the user in the validation report. They can even click on the map to see expected geometry should be areas, what the entity handle is, and this will give them a better indication of what needs to be repaired in order for their submission to be successful. Let's take a look at a successful submission, and here we have a success where the FME Lizard's development plan was successfully submitted. And here's a reference number for your records, and if you need next steps to get an electrical permit or a plumbing permit, here's what you can do. You'll also notice that we're going to have to pay our application fee by a certain time. This is 2 business days later. And should we need to do anything else, we can return to the digital plan submission portal. Some best practices to keep in mind: keep it simple and don't overload the end user with a ton of published parameters to fill out. While you're using the published parameters, be sure to take advantage of setting which ones are optional and which ones are required. It's also beneficial for you to report back to the user about more than why did the submission fail. So don't just put simply submission failed, try again later. Because the power of digital file submission is that it can provide detailed validation reports about all the geometry and the attribute data that was incorrect. So be sure to include this in the report so your end user knows exactly what needs to be corrected. Lastly, the key to this workspace is integrating valid data into your system or multiple systems. Since you know only valid data is going to pass the workspace, you should be able to integrate this directly into your database or multiple systems if data needs to be available in a variety of formats or for different teams. Validating, integrating, and notifying stakeholders can all be integrated into this one workspace to keep things moving as efficiently as possible.
So yesterday, we discussed data streaming. This is an exciting new feature to the FME platform. And today, we're going to take a closer look at what streams are for, how to create workflows in FME for both spatial and non-spatial streams, and showing off a few demos. A key consideration when it comes to streaming data is understanding the difference between batch and real-time processing. Batch is where you're taking pre-collect data and reading that into the workspace. Real-time data, on the other hand, is where you're taking data that's generated near real time and it's streaming to a connector in the workspace. Real-time processing is especially useful when you need to handle events as soon as they occur. This is great for uses like data applications with live feeds and time-sensitive event notifications. Common use cases for streaming include sensor data, live traffic monitoring, and fleet tracking. And these are examples of live, medium, and high volume streams. A typical stream workflow gets data from a stream source and passes the data into transformers and then outputs the data. In this diagram, we have a connector that streams data into a workspace, which filters the data and sends it to a database. A common source are message queue and broker applications, which collect data from other technologies, such as sensors or GPS trackers. Message brokers manage streams and topics, which you can think of as folders that hold event messages until a client pulls them out of the queue. Brokers provide many benefits, such as data pre-processing, guaranteed delivery, where the message will not be removed from the queue until the client confirms that it was received, and they're great for both high and low volume streams. For example, you could have an IoT sensor that sends data to a Kafka message queue, which is then read in FME. Stream connectors in FME include a mode parameter that lets you choose between batch or stream processing. While in batch mode, a set amount of features will arrive in the connector, and then you can use feature caching and running to single or up to certain transformers. And this is really useful for the authoring stage of streaming workflows. Streams technically never end, so the workspace will be running indefinitely. And to make sure that happens, our connectors can be switched to the streaming mode, and that way your workspace will run until it is manually stopped or interrupted. So now let's take a look at authoring tips for streaming. The first tip is how to deal with grouping of data. Features can be grouped in a number of ways, such as by their attribute, spatial location, and/or event time. Stream mode changes the way you understand authoring an FME workbench. In the past, when grouping features, you're often completely fine to set the grouping mode to process at end, which is blocking mode, and then just forgetting about it. However, this mode does not work when you're working with streams because there is no end to the workspace. So time is now an important factor, and transformers need to know when to release their features and feed them to downstream transformers. When in stream mode and using grouping, you must set the group mode to process when group changes, which is the advanced mode. Time for a transformer spotlight. New to FME 2021 is the time windower transformer, which can assign a timestamp and time window attribute to features based on when they pass through that transformer. Let's say you have a 30-second window, and every feature that passes through the time windower in each 30-second window gets a specified window ID. In the first 30 seconds, it will get an ID of 0, and in the next window, 1, and so on. In this example, we only want the most recent location of each vehicle in each window to avoid excessive data storage. Using the time windower, we can assign a window ID to all the attributes based on 30-second windows, and then based on each window, we can sort them in chronological order and sample the last feature, which would be the most recent location for each vehicle. Since the sampler and the sorter are considered blocking transformers, you have to set the group mode to advanced to let them pass through. So you can also use readers in streaming workspaces, but the order of operation matters. Many transformers that involve comparisons between different data sets have a parameter that guarantees the workspace will read the comparison feature before incoming stream features. For example, we have the clippers first, candidates first, and filters first parameters. When it comes to controlling the order of operations with transformers where multiple output routes are involved, you can use the runtime order to specify when each route will be executed. This matters when you need to make a certain transformation happen before or after a different transformation. When using creators in your streams, you must set the create at end parameter to yes. When you need to use multiple creators, make sure you check the creator runtime order. In this example, we have a feature reader that contains clipper features, and we want to make sure that runs first. So we can use the creator runtime order to make that one run first. There are a variety of outputs that you can use with stream workspaces. If you simply want to write your data out, you can use database connections. And when you're writing to databases, you'll want to make use of the features per transaction parameter. That way, you'll be committing the features in batches. This requires some fine-tuning to determine the optimal amount of features to commit per batch, because you don't want to send excessive features per transaction, but you also want to commit a safe amount so you can minimize data loss in case your stream is interrupted. Other options include live data feeds to web applications so you can keep up with near real-time data. You can also generate HTML reports, which summarize your data in comprehensive charts. And if you just want email notifications for events, our emailer transformer comes in handy. So publishing your streams to FME server is incredibly easy. Our new interface includes a dedicated section for building and managing your stream workflows. To set up a stream on FME server, simply give it a name, choose your workspace, assign one or more engines to it, and hit the start button. It's that simple. And with the power of multiple engines comes the ability to scale up your streaming workflows. For instance, your data stream pushes data at 3,000 features per second, but your workspace can only process 1,000 per second. So if you assign 3 engines to your stream, you can keep up with that stream data source. So here are some tips and best practices for optimizing your streams and getting the best performance. Separate your stream and business workflows. Don't make your stream workflows do more than they need to. Not only will this make your streams easier to manage, but it will also prevent major mistakes from occurring, like accidentally sending 1,000 event notifications to your boss. Keep it simple. We all love big workspaces, but this can cause some major performance issues with streams, especially when using the advanced group by mode, which can cause a cascading delay effect where all the transformers are waiting for the group to change before they can process. To separate your stream and business processes, make use of our other features such as the FME server notifier, FME server job submitter, and webhook triggers, so you can make use of job chaining, and you can execute your business workflows separately, such as generating your HTML reports and sending emails. The next major recommendation is to remove unnecessary features and attributes as soon as possible. This will reduce your resource usage. And watch out for lists. They can grow very quickly and take up your resources, so only use them where absolutely necessary. And now let's jump right into the demo. In this example, we're going to be using a geofence with our message stream to filter just the features that fall within the City of Vancouver boundary. So we have our admin boundary shapefile here, which contains the City of Vancouver boundary polygon. And we also have our Kafka connector, which is connected to our message broker, which contains the live data feed of the locations of the City of Vancouver's vehicle fleet. We also just want to filter it to the location of the SUVs. And from here, I can verify that my workspace is in stream mode by opening the Kafka connector and seeing that the mode is set to stream. And I also want to make sure that my City of Vancouver boundary arrives first in the Clipper. So that's where I have the Clippers first set for the Clipper type. And to run the workspace, I just need to hit Run Entire Workspace. You'll notice that the boundary went first, and the messages from the message broker will start arriving now. So now we're going to go into a more complicated scenario where we have a low volume stream of power outages based on sensors on a grid. So we're connected to that live feed through our Kafka connector, and we also have a Google BigQuery connector over here, which is connected to the live locations of the service vehicles. And when a power outage is detected, the neighbor finder is going to look for the 2 closest vehicles to that power outage and send an HTML report in an email to the dispatcher. So an important note about this workspace is that since it's low volume, you're going to end up with a situation where we have 3 power outages that show up in this stream, and you'll have only 2 come out of the output of the neighbor finder. This is because when the 3rd arrives at the neighbor finder, that's considered a new group, but it's waiting for that group to change to output the feature. But that's not good in our situation because we want that notification to go out as soon as it happens, because this is a time-sensitive situation. So to deal with that, we have a dud feature workaround, which creates a fake outage ID. And since we have the runtime order of the JSON flattener to submit a feature in the attribute creator number 2 last, what will happen is that the features will end up in the neighbor finder. And when it's waiting there, The dud feature will be passed in last and will flush out all waiting features in the neighbor finder and make sure that all features will be pushed out and it won't have to wait for the next outage to happen. So we can run this now and you'll see it in action. So to learn more about streams, we have 2 great webinars coming up soon, and please sign up for them if you're interested. We've also published lots of tutorials and articles on the knowledge base, going through the different use cases of streams and how to build these workflows in FME. And I'm off to you, Jen.
So now we'll go back to empowering data modernization. So organizations and government agencies are rapidly modernizing their infrastructure to maximize the value of available data. They're replacing legacy systems and implementing high-performing systems that can handle the volume of workflows and service requests that are exponentially increasing. And they're doing this with the cloud, as a lot of cloud providers have specific services designed to meet these needs. Organizations who embrace the cloud can often increase the speed that they can set up systems and services to handle their data. The nature of the cloud means that if requirements change, organizations can quickly pivot or set up new systems. No longer do they have to wait for long procurement processes to purchase expensive hardware. With the cloud, they can be up and running in minutes. So for cloud support within FME, AWS functionality within FME has been around for several years. And you can see on this slide, many of the AWS services that FME can integrate with, either using readers and writers or connector transformers. If you're wanting to automate your data modernization workflows, FME Server has built-in functionality that will trigger automations using Amazon S3, so looking for changes within a bucket, a new message in an SQS queue, or a notification from SNS. FME Server can also output to those 3 services. Azure functionality within FME has definitely taken off over the last couple of years, and we're seeing more and more customers migrating to Azure. You can see on this slide many of the Azure services that FME can integrate with, using either readers and writers or connector transformers. If you're wanting to automate your data modernization workflows, FME Server has built-in functionality that will trigger automations based on an Azure Event Grid event, and FME Server can also notify an event grid topic. The last of the 3 big major cloud providers is Google. So you can see on this slide the Google services that FME can integrate with. Again, we have readers and writers that can integrate with Google, as well as connector transformers. However, if you're wanting to automate your data modernization workflows with Google Cloud, you can use Google Cloud Functions to post data to an FME Server webhook. FME Server can also make HTTP requests back to other services if data or messages need to be passed out. This kind of integration also applies to AWS and Azure too, where you could set up FME Server webhooks to receive data from AWS Lambda or Azure Functions. As part of empowering data modernization, a lot of customers will move all of their data into the cloud, and we want to make it easy for end users to work with that data. And to show you how easy it is, let's jump into a demo. On the left-hand side, I have FME Workbench open, and on the right, the Google Cloud Platform console, and we're looking at the contents of my Cell Signal data bucket. At the moment, there's nothing in my bucket, but we're going to use FME to upload a CSV file. In FME, I'm going to add the Google Cloud Storage Connector transformer to my workspace. Now I need to set up this transformer so that it can connect to my bucket and will tell it which file to write where. Inside here, you can see there's a few parameters we need to set. So the first one will be my account. I've already created a web connection for my Google Cloud Storage account, so that's what I've selected here. For project ID, I'm going to click on these 3 dots and it will let me browse for the project that I'm working in. After that, we can choose our action. With all of the cloud storage connectors, so this could be the Amazon S3 connector or any of the Azure storage connector transformers, you can choose whether you want to delete, download, list, or upload data to the cloud. I've chosen upload because we want to upload that CSV file to my bucket. You have the option to upload a file, folder, or attribute, I'm going to leave that as file and then choose the CSV file, which is this cell signal dataset. Next, I need to choose which bucket I want to upload it to. So you can see in the Google Cloud console, I'm uploading it to a cell signal data bucket. And then I'm going to leave the path as it is, as I want this file to appear in the root path of this bucket. Now that I'm happy with how that's configured, I'm going to press OK. I'm going to add a creator so that there will be a feature that gets passed into the Google Cloud Storage connector to make sure that it runs. It won't take long to upload this CSV file. It's not a very big file. You can see that's already completed. And then if I go into the Google Cloud console and refresh this page, you'll see that the cell signal CSV file has appeared. So now that we've seen how we can use a cloud storage connector transformer, here's a tip if your data already lives in the cloud and you need to read it into FME for processing. You can use the web file system to browse for and access your data. If you don't see your cloud service listed, have a look on the FME hub to see if it's available there. Another tip to consider is where your data rests and where will it be processed. This is a map of the Google Cloud Platform's locations and network. The blue lines are their existing network, and the green lines are submarine cable investments. If your data is located in a European data center and you're based in North America, you can see how much further the data has to travel. The further the data has to travel, the longer it will take to process. To speed up processing, FME likes to be as close to the data as possible. So if you attended part 1 of this presentation, you'll remember how we talked about the importance of spatial data and how data cloud services such as Snowflake and Google BigQuery are offering support for spatial data out of the box. Google BigQuery, if you're unfamiliar, is a fully managed serverless data warehouse that enables scalable analysis over petabytes of data. This is useful for organizations who have lots of data to store and analyze, and including location information in those data sets is very common. Many critical business decisions revolve around location data. For example, you may record the latitude and longitude of your delivery vehicles or packages over time. You may also record customer transactions and join that data to another table with store locations. BigQuery.js lets you analyze and visualize geospatial data in BigQuery by using geography data types and standard SQL geography functions. You can connect FME to Google BigQuery to query your data and then process it within FME. You could use this location data to determine when a package is likely to arrive, or to determine which customers should receive a mailer for a particular store location. To get data into Google BigQuery, you can load from Google Cloud Storage or from a local file by creating a load job. This data is limited to a few formats such as CSV or JSON. You can also connect to other cloud providers like Amazon S3, for example. If you have your data in other formats, you can use FME to load data into Google BigQuery. So let's take a look at how to do that. So in this demo, I'm going to show how to write data into Google BigQuery. So I'm going to add a CSV reader, and this will be the same data set from the previous demo, that cell signals CSV file. Now, if I click on the parameters for this reader, I can see that there's a longitude and latitude attribute or column inside this data set. FME has automatically assigned it as an X coordinate and a Y coordinate, so this data in our workspace will be spatial. If you aren't using a CSV or Excel reader, you'll be able to use a vertex creator and a coordinate system setter to achieve the same thing. Now we've got our CSV file added, you could add any transformers here that would do whatever you need to do to your data. So if you needed to do some analysis on it, maybe change some of the attributes or the values, or do some validation, this would be where you add those in before you write the data out into Google BigQuery. For now, I'm going to leave this as is. I'm going to add the Google BigQuery writer and connect that to my CSV reader. But before I do that, I need to set up my parameters. We need to give it a credential source. So for this, I'm going to set up a web connection. and use my BigQuery web connection account. Again, just like we did in the Google Cloud Storage connector, we need to choose our project. So I'm working in the same project as before, and we need to choose our data set. As you can see on the right-hand side, I've got two data sets set up in here, the CSV and the cell signals. So you can see the cell signals here doesn't have an arrow. There isn't any data in this data set currently. So we're going to be writing into this cell signals data set. As FME picked up our longitude and latitude coordinates and assigned them to be X and Y, we're going to change the spatial type here from none to geography and give this column name _geog. This is the attribute or column that will store the geography information for when it gets written into Google BigQuery. Now I've set all these parameters up, I can add this to my workspace. And I'm going to connect those two together. And you can see these are all of the attributes that we're going to be writing out. The one last thing that I'm going to do is change the table name to be cell signals and press OK. Now I'm going to run this workspace and we should shortly see all of that data appear in Google BigQuery. But while that's running, you may have noticed as I was typing in here, there's also a Google BigQuery connector transformer. So we can take a look at that while the workspace runs. Again, inside here, you would set up your account, your project ID, but this has some slightly different functionality. So the BigQuery connector transformer will let you query your data that's currently in BigQuery, and you can do that by writing an SQL statement in here. You can also load data into Google BigQuery. You're currently limited to the CSV file type, but you can load that as a file from your local system or from Google Cloud Storage as well. If you're wanting to take a format that's not CSV, I would recommend that you use the reader for that format and then connect it to the Google BigQuery writer. It looks like this translation was successful, so I'll delete the Google BigQuery connector and let's go back and refresh this page. We should now see when the page reloads that the cell signals dataset has some data in it. So we can see here the cell signals table that we wrote. We can see the details about that table. And we can also preview it. So we can see all of the data here in a tabular form. Because we have the longitude and latitude and we know that it was assigned coordinates, we can also view this in GeoViz. So I'm clicking on Export, Explore with GeoViz. Once GeoViz has opened, you can run the query to select all of your data. And then once it appears on the map, which will be over Vancouver, you can click on any of the points and a pop-up will open showing all of the attributes for that point. One of our FME customers uses Google Cloud and recently was interested in how they could use FME to help with their data modernization. They have end users uploading data into Google Cloud Storage, and the GIS team needs to get that data into BigQuery. It's possible to automate this with a combination of FME Server and Google Cloud functionality. When new data appears in Google Cloud Storage, the storage event triggers within a Google Cloud function are able to notify FME Server via a webhook. FME can then process the data however they need, which could be a validation process, and then load it into Google BigQuery. Another piece of FME Server functionality that this customer liked was FME Server apps, which Chris demonstrated earlier. This means that users don't need to be familiar with Google BigQuery or FME. They can just upload their data straight to an app, and then FME will take that and process it and load it into Google BigQuery or into Google Cloud Storage. And again, this isn't Google specific. We support this functionality and type of workflow for AWS and Azure too, depending on wherever your data modernization efforts are. So a tip for automating your data modernization workflow. Take advantage of the triggers and actions that we have available in FME server automations. If your cloud provider or service isn't natively supported in FME, see if they have an API or support webhooks. You can then combine this with what I'm calling FME's generic functionality, which is the webhook trigger or HTTP action within FME server automations. And here are some resources if this is what you're interested in. We have a few blogs available online, as well as a community tutorial that walks through the process of automating the data upload to Google BigQuery. So next we'll move on to our last set of scenarios, which are focused on cultivating data cultures, which is another major theme that we're witnessing with our customers. From the top executives through to department managers and professionals that are implementing these programs, everyone is working together to ensure that the right data is available to the right people at the right time. There are two scenarios in this section, showing how FME supports the flow of data by connecting systems together and providing data sets that are trusted that can be shared and accessed by the right people. So the first scenario that we'll look at is application integration. As you'll remember from yesterday, we talked in depth about data integration, and that the goal of application integration is to ensure that data users can access the information they need in whatever system makes most sense for them. It eliminates the duplication of manual data entry and bridges data between systems. In order to take your application integrations to the next level, today we'll look at the functionality that you'll need to be familiar with within FME. So in this scenario and set of demos, we'll use a simple example of connecting FME to Microsoft Teams to post a message to a channel, a frequently requested integration on our FME community. This will show us how to manage and set up web services and connections, how to make API calls, and then create a custom transformer. This will set you up with the basics so that you can delve into more advanced application integrations. So we'll start with web connections. If you're frequently connecting to the same application or service, you'll want to set up a web connection and a web service that will save manual repeated authentication. Before we jump into this, let's go over the difference between a web service and a web connection. So a web service is a definition which contains all of the information that FME needs to connect to that service and how that service expects to authorize FME. You'll find details on how to do this in the specific services documentation, and you need to set up your web service before you can create a web connection. A web connection is where you enter your user credentials so that you can connect to a web service using the already registered service in FME. So before we go into a demo, here are some tips and tricks for setting up your web service. The first one is to check whether your service is already supported, either in FME Desktop or FME Hub. You'll need to identify which type of authentication is required and check that FME supports it. Find the services documentation and application registration page for your service. And then you can also copy or adapt existing web services or use them as a guide if the service that you're trying to connect to has a similar method. If you're still stuck, we do have resources available on our FME community that might help you out. So for part one of this scenario, we're going to take a look at the Microsoft Graph web service and web connection in FME. So our number one tip was to check whether the web service is already supported. So to do that in FME, you can go to Tools, FME Options, Web Connections, and then Manage Services. Any web services on the top of this list are already installed into FME Desktop. Any web services at the bottom are available to download from FME Hub. So the Microsoft Graph web service is actually available on FME Hub. I've already downloaded it to my FME Desktop. However, this won't work out of the box and will require some configuration. So I'm going to briefly take you through that configuration. For more information about how to configure web services and web connections, specifically for Microsoft, I recommend reading their documentation. So they have some good pages on their website for understanding authentication and authorization, the basics, and also how to register your app in the Azure portal, which is something that I'm going to briefly show you. In FME, you'll want to click on the web service that you want to configure, And then you'll see a list of parameters that you need to enter in here. So to get this information, such as the client ID and client secret, for Microsoft, you'll need to register your application in the Azure portal. So here I have my MS Teams application open, and you can see the client ID is available on the overview page. So this matches what I have set up in FME. To generate the client secret, you'll need to click on the Certificates and Secrets tab on the left, and you can generate the secret down here. The other thing you need to check is that the redirect URI matches what it says in Azure Portal and FME. One of the other things that you'll need to make sure is that the API permissions for this application are set correctly. So you can see here there's a lot of permissions listed to do with channels, files, groups, and teams, because that's what we need to give access to be able to complete this scenario. To find out exactly what permissions you need, because it's best practice to assign the minimum amount of permissions that you need, you can find this out in the Microsoft Graph API documentation. So the primary purpose of this scenario is to be able to create a chat message in a channel. So opening that documentation here, you can see the first item is the permissions. So the delegated permissions, which is what FME will be using, are the channel message send and group read write all, which you can see are configured in here. Once you've configured your web service in FME and in Azure Portal, you can test your web service. If you haven't recently signed in and tested with it, you will be prompted to enter in your username and password, potentially confirm permissions, and then if your test is successful, you'll get a notification like this one, and you can go on to create your web connection on this page. So now that we've successfully authenticated, we'll need to connect to an API. Many modern applications or services that you want to integrate with will have an API, so you'll need to understand how to use the HTTP caller. Each transformer makes one API request. The API documentation for your service or application will tell you how to format the request, which you can enter into the HTTP caller. Another thing to consider is the response format. A lot of APIs will respond with JSON, so you'll likely want to be familiar with the JSON fragmenter or JSON flattener and connect one of these transformers to the HTTP caller to pass the response. So this tip is something that everyone working with APIs should do, which is to find and use the API documentation. If you're lucky, the API might have an interactive tool that lets you test out API calls and see the response. This lets you quickly check that you're setting up the API call correctly and getting the response back that you're after. You can then copy the settings over into the HTTP caller. An FME server has this, as well as Microsoft Graph. So let's go and try this out now. So the primary purpose of this transformer that we're going to be creating is to post a message to a channel in Microsoft Teams. So on the right-hand side, I have open the documentation for the Microsoft Graph API, and I have the page open for the create chat message in a channel. So you can see here in the documentation, we have the permissions that we need. So these should have been set up and configured in part 1. And then just below the permissions, we can see the HTTP request that we would need to make in order to post a message to a channel. So that request is here. We can see that it's a post request, and that in order to correctly make this request, we're going to need the Teams ID and the channel ID before we can post a message. So this is going to require us to chain multiple HTTP callers together in order to first obtain the Teams ID, second obtain the channel's ID, and then make another call to the API in order to post the message. So I'm going to take a look at the HTTP caller that we have first, which is going to be the one that finds out what team we belong to. So I'm also going to open the Graph Explorer on the right-hand side as well and show you what that looks like. So this is the API call that we're going to need to make first, which is a GET request to find out all of the teams that we've joined. So you can see I'll open the HTTP caller at the same time. So the Graph Explorer lets you test out API calls in your browser before migrating the settings to FME. So if your API service that you're interacting with has something like this, it's a really good way to check that you're making the request correctly and that you're getting the response back that you're looking for. So we can see here it's already ran this query. This is the URL that it called, and that we can see the response down here in this response preview. So this is what we would expect to get returned when we run this in FME. We also need to configure the HTTP caller correctly. So you can see that I have the same HTTP request URL in here that we have in the Graph Explorer. We also have the same HTTP method. So you can see at the top here, it's a GET request. And again, we have the method set in here. Because there is no body for this API call, this is blank. We don't need to set that in FME. And then the last thing that we've got in here is the authentication method. So this is set to web connection, and we're using the Microsoft Teams connection that we created in part 1. So connected to the HTTP caller, you can see inside this workspace that I have a JSON fragmenter transformer. This is because, as you can see in the Graph Explorer, the response coming back from this API call is JSON. Depending on how many teams you've joined, this count value might be higher than 1. So I've added a JSON fragmenter so that if more than one value came back, it would split each of those out into its own feature within FME. I've also set up a basic JSON query, which looks for the value key within the JSON that's returned, and then we'll pull out all of the values below that value key. So we can see in the response in the Graph Explorer that we have this value thing here. So the JSON query is basically pulling everything that's within it. So everything that I've highlighted here. Because I need to make multiple API calls to get the channel ID as well as the team ID, I've decided to prefix the new attributes from this response with team. Just so further on in my workspace, I know that these relate to the team ID and the team name. So I've chosen to expose the ID and the display name, which I got from the response. So the display name is here, and the ID is what we'll need in future API calls. I've exposed those so I can use them downstream in my workspace. So that's just a quick look at setting up the HTTP caller in order to start making some API calls. So now we've got our web connection and our HTTP callers, how do we make this easy for other people or our future selves to integrate with these applications and services? This is where we introduce custom transformers. Among other functions, custom transformers help to reuse content by encapsulating a sequence of transformers into a single object, and this can be reused throughout a workspace or shared with colleagues. You can use advanced functionality, so things like looping and parallel processing. It also helps keep your workspaces tidy. By condensing chunks of content, the workspace canvas becomes less cluttered. In this screenshot is what the full FME workflow looks like to connect to Microsoft Teams. Imagine giving that to a customer. They wouldn't really know where to start. Creating a custom transformer is much nicer. So one tip if you're making custom transformers, make it really easy for users to define their input. FME transformers all have parameters whose value can be supplied by attributes or by user input. The same is true of custom transformers. Because a custom transformer can be reused in multiple places, it's important that these inputs are flexible. If you plan on sharing your custom transformer, use a linked transformer. A linked transformer is one whose definition is stored outside of the workspace in its own file. Each instance of the custom transformer is linked to that definition. Any workspace can have access to that custom transformer, so every workspace will be using the same version of that transformer. You can also upload your custom transformer to the FME Hub and share it with the community. Let's see how you can create custom transformers and manage user input. So for our third and final demo of this scenario, we're going to be taking a look at how to set up a custom transformer. So the easiest way to create a custom transformer in FME is to select all of the transformers or objects that you want to be inside a custom transformer, right-click, and then select Create Custom Transformer. That will then bring up a dialog and ask you to enter the transformer's name, and then you will end up with a green transformer on your canvas, just like this Microsoft Teams connector that I already made. So once your custom transformer has been created, there are a few more things that you can do to make the user experience a lot better. When your end user gets this custom transformer, they don't want to have to know every single transformer that they need to go in and configure, for example, with their web connection. There's several HTTP callers inside this custom transformer, and each of them they would need to configure with their web connection. The easiest way to do this is to set the web connection up as a user parameter. So you can do this, instead of just choosing the web connection in here, you can click on the drop-down, user parameter, and then create user parameter. You can then define the user parameter, give it a logical prompt, choose the configuration. So for this one, you can make sure that they're only using Microsoft Graph web services. For example, using like a map-then or a HDFS web service isn't going to help someone authenticate in this case. So I've already got my MS Teams connection parameter set up. So then I've replaced that in every single HTTP caller, which means the end user of this custom transformer only needs to specify their web connection once, and all of the HTTP callers will use it. Another important parameter that we need to create is for the message that we want to chat out in Microsoft Teams. So for this API request, there's an upload body which contains the message which will get posted into Teams. So here, that content of the message I've turned into a parameter called chat message. So this means when the user is setting up their custom transformer, they will be prompted to enter in their message. They won't need to know exactly which HTTP caller to find inside here to configure. There's a few more user parameters, but we can take a look at them using the new Manage User Parameters dialog, which is new in FME 2021. So here we can see a list of all of the user parameters that I've configured for this custom transformer. You will recognize the Microsoft Teams web connection parameter. Because this transformer does multiple things, or can do multiple things, I've added a choice parameter here, which gives people a list of actions that they can take. If you're interested in those other actions or seeing in more detail how the custom transformer was created, you can watch the YouTube video that we'll have available. The other required user parameters are team and channel. So if a user wants to post a message into Teams, they will need to specify their team and the channel that the message should get posted in. Because some of the other actions don't relate to the message, this parameter is not required, so it's optional. But if the user wants to post a message, they will need to fill this in. So now we've taken a look at all of those user parameters, we can go back to the main workspace, make sure this transformer is configured correctly, and then run it. So we can see I have my Microsoft Teams open on the right-hand side. So my team is FME with a space notifications, which you can see up here. And then the channel, I'm going to post it to the FME with no space notifications. So we should see a message appear in this window. I've already selected my Microsoft Teams web connection. So the last thing to do is make sure that the message is what I want to send. So I'm just going to post a message that says, "Hello, FME World Fair attendees." So now I'm happy with that. I can run this workspace, and we should see in a few moments that message appear in Microsoft Teams. There we go. So hopefully at the end of all three of those demos, you'll have an idea of how to build a web service and a web connection, how to use the HTTP caller, and then how to wrap it all up into a custom transformer, which makes it really easy for your end users. So a few resources if you're about to start doing some application integration with FME. We do have quite a few posts on the FME community which help introduce web connections, how to connect to different APIs and work with JSON, and with a HTTP caller. If you're interested in more information about custom transformers, I recommend that you take a look at the Desktop Advanced Training course, which we have available online for free.
For our last example, we're going to be talking about open data portals. And specifically, we're going to be looking at the considerations you need to think about before building one of these yourselves. In particular, I'm going to be talking about how to provide choice for your users, how to keep the data up to date, how to choose a platform, and how to enable developer access and the ability to build apps on top of the data. And I skipped a point there because on purpose, Chris today talked about sharing quality data and specifically data validation. And there are so many great use cases for validation in FME. We won't cover it here, but I highly recommend checking out our knowledge base for validation examples. So our first consideration is building for flexibility. And this is all around how do you build a portal to allow the end user choice when they're picking what data they want. Because remember, not everyone needs the same set of data and use cases can vary. And you really want to enable all of those choices to be picked by your end users. So there's a few specific things in FME that you can do to help. The first is using a generic writer format. Now, this is a very interesting format because it is not one specific thing. You can actually use it to provide the user output such as shapefile, Excel, CSV, you name it. It is a fantastic single feature type that you can put on your canvas and away you go. We'll look at it in the demo in brief. The other choices you can offer are spatially filtering the data down to a specific component of that data or subset, and filtering to provide more choice. So perhaps you only want a small subset of the data where the attribute matches the search that you're trying to create. For example, instead of all the parks in the Lower Mainland of Vancouver, you simply want the dog parks to come back to you from the portal. And the way all of this is driven is by using published parameters. And in fact, in FME 2021, we've revamped how published parameters look and feel, and there's a lot more power coming to this feature, which is fantastic. And the beauty of all this is it's really future-proof because you can set it up, create that workflow, and then later on, let's say you want to add a new format to the output, well, you can quickly add that in, increasing the choice for the user, and it's quite easy. So future-proofing is a very big deal. Our next consideration is how do you keep all that data that's living in that portal up to date? And I've got a really good tip for that. One of the transformers that we see used very, very frequently with databases is change detection, and specifically the change detector transformer. So you can take two sets of data, compare them together, and the change detector will tell you just what has been changed or added or removed from that set of data. And then you can just put those changes into your portal backend database or however it is being set up. And that's really efficient. You're not truncating a whole table and loading up all the data again every night. Instead, you're just pushing a few records to be updated, which is great. And another nice tip is using FME Server to automate these processes can be very effective. So you could be sleeping while a scheduled task runs every single night to update that data set. And one final note on this is even sensitive data can be anonymized and shared within a public open data portal. I've seen really good examples of using crime data where the actual location is being moved slightly from the real world area where that crime happened so that you can still provide all that information to our end users, but they don't have the very, very nitty-gritty specifics. Still a very powerful tool. I've also seen the ability to strip out names using FME or addresses from sets of data and then still making that publicly available. The next consideration is what platform do you choose to build this open data portal? And these can be very, very simple. I'll show in a demo one version of it just purely using FME Server. But of course, there are purpose-built tools out there that our users are using every day to provide data to their end users. ArcGIS Online, and in particular, the open data component of ArcGIS Online is fantastic. Socrata is another great one that we've had lots of users using with FME. CCAN is another one that we've added in 2021, the ability to connect to it and get files, and also the ability to write data to it, which will be coming in 2021.1. A final note is using something where you cobble some services together to build a nice data portal. A good example of that is using AWS, so having the data stored on S3 buckets, using EC2 to spin up the machines to provide the infrastructure and the server, and then storing all that data and backend information in an RDS database can be very, very effective. We've seen some good customer examples of that. Again, talking with your organization, stakeholders, assessing the different needs of your group can point you in the right directions. And our final note here is, how do you provide the most value to your audience? And one of the great ways to do that is giving developer level access to the data. There's a nice way in FME Server to do this using webhooks. And that allows you to use a call within your own application to run the workspace on FME Server and get the data back. But of course, many of these purpose-built applications have things like APIs, RSS feeds, ways to integrate with the data and even get it as soon as it's updated, which is quite powerful. The other note here is that hackathons and community engagement is just such a fantastic way to get applications and ideas forming around all that data that's being served out to the public and providing value that maybe your organization hadn't even thought of before, but some ingenious developer group or students even came together and built something fantastic for the community. So we really love to see those hackathons and participate in them whenever we can. Now at this point, let's jump ahead into a demo. Let's look at two brief examples of open data portals in action. The first, we'll build a very simple service using FME Server and specifically FME Server apps to serve a set of data to our end users. And in the second, we'll look at the state of Arkansas and their GeoStore application that they've built using FME Server on the back end. Now this is the map-based data distribution demo, lives on safe.com/demos. And what's great about this is you can review it, build it yourself. We've given you the workspaces and all the materials needed. But I'm just going to run through the example. We talked about giving users choice, and in this case, we have a number of parameters made available to our users to be able to choose the data that they want. And in this case, let's pick some bus route data. And we'll now select an area of interest. So we've got our map picker popping up for us. I want to select an area in Vancouver, right around downtown. There we go. Let's close that off and confirm it. And we'll pick a coordinate system as well. Let's go with lat long. And remember choice. Now here we have a number of different output formats. In this case, I'm going to pick Google KML, and we will run this. And what this is doing is going and running our workspace and providing the data out to our system. Great, super easy. And if we go open up that set of data, I'll transition over there. And now let's go open up the output data set. We've got this in Google Earth. And as the map zooms in, we'll see the data that we requested right on the Earth. Perfect. So again, this is using a format that's very intuitive. Many people can use it from different walks of life, and so you can really empower your users. We'll leave Google Earth Pro now. And at this point, what I want to do is walk through the workspace. So open up FME. Now we're inside FME, and the thing that I want to show you is how those published parameters actually work. That is the big key here. And so I've got this user parameter manager. You can see we have 4 parameters. in this workspace. Those are the same fields that we used on the app via the browser. And what's great about this is you can really specify what information you want to make a choice to users. So for example, output formats here. We've provided a number of different formats that a user can pick from, but this isn't a free-for-all. You're really specifying exactly how this workspace will work. Click OK there. And remember, those parameters give the workspace instructions. So how does that actually work? Well, here's a few key examples. In the geometry replacer, the geom, this is that polygon we drew on our geometry picker, those coordinates will pop in here right into the geometry source. So again, whatever is being sent in by the user, it's getting picked up as the workspace is run. So those coordinates will come in here. We feed that over to the feature reader. That's again where that choice comes in, another parameter here of which layers to grab. What's really neat here is that the geometry that's coming in from the geometry replacer and from the actual end user is being fed into the feature reader, and using a spatial filter, we can pull only the data that falls within those layers that are within the polygon. So the polygon gets fit in as the initiator, and then just the data coming out is what's met with those guidelines. And then the clipper comes in and it just strips out any extra streets that are within the filter, but then start to stretch out beyond the polygon I drew. So we clip it right to that initial shape. We style it for KML if KML is your choice. But the last part I want to focus on is actually just the writer. And you'll notice there was 5 different formats that a user could pick, but in the workspace there's only one writer feature type on the canvas. How does that work? Well, I'll show you. It's actually a writer, a special kind of writer called a generic writer. And in fact, in here, we're making use of those other 2 parameters. You can see the first is the coordinate system is linked to whatever the user inputs. And the second is the format. And this is the power of the generic writer. So you've got the ability to tell this writer at runtime which writer format do you want to use. And so we've made a nice drop down here with the appropriate names so that this writer can switch between shape or KML or PDF even, and it's fairly seamless. And so that writer, highly recommend taking a look at the documentation for this. It's really, really powerful. And what it does is it's future-proofing this workspace for you to come back in the future and simply add a new format with ease, because all you need to do is change the parameter settings here to accept a new format. It's very simple. And so that's how this works. This is kind of a secret sauce, this generic writer, but it can really simplify your workspaces. And when you look at the entirety of this workspace that was driven by that app, it's not very complicated. So we'll leave Workbench for now. Now the last example here, we're going to look at the Arkansas GIS Office's GeoStore website, an open data portal where they house lots of different data sets for the state of Arkansas. Now they've wrapped quite a, sorry, start again. For our last example, we're going to look at the state of Arkansas's GIS Office open data portal. And what they have here is a number of different sets of data that they've provided to the public. We're going to go and grab one from transportation, keeping with our theme. And in a moment, you'll be well aware that FME server is somehow involved here. As we go to download the set of data, you can see the same idea of different choices being made available to the end user. So in this case, we can pick between different counties, which is great, have a big list there. And again, many different file formats. I'm just going to go ahead and pick KML. And finally, projection. Now, in their case, they have some specific projections set up for their state, so you can pick one of those. And then we could enter our email and download the data, and away we go. Now, in their case, this is more of a complicated example. And as well, they've wrapped FME server with a different front end than just an FME server app, like our first example. But it shows you the same power, the same ability to make choice and data available to those that need it. Final note here is just a few resources to point you towards. We have a great webinar on open data portals, and the link is here, of course. But also we have a great blog and ebook. And the ebook in particular will talk about everything I just touched on in quite a bit more detail. So I highly recommend, if you're interested in building an open data portal yourselves or within your organization, the ebook is a great place to start. And the demo I showed, you can absolutely grab it from this link here, play with it yourself, take the workspaces and files, and be able to run it and spin it up very, very quickly. Wow, another whirlwind tour through the fairgrounds today. We've looked at a number of different examples, lots and lots of demos, fantastic detail here by the team. And to summarize, again, all of these examples are making use of data to empower all of the users of it to make better decisions. Again, incredibly powerful. We touched upon streamlining operations, again, showing how automation can be incredibly impactful. Data modernization, utilizing the cloud, and cultivating data cultures, bringing those applications together within your organization, sharing the data with the public. All of these are an effort to make the data world a better place for everybody. Thanks all for tuning in. We want to thank everybody for joining us today. And of course, if there's any questions, we're going to be happy to answer them. Please ask away in the question panel. After the live Q&A, make sure to head back to the FME World Fair map to see what rides and attractions at the event you can visit next. Visit the agenda tab in your left toolbar to see upcoming sessions at the World Fair. Thank you, everybody.